the early Viz conferences back then. The company does a lot of different things now, but those people in that business might be familiar with VTK, a software product that is, we like to think of the de facto standard in scientific visualization circles. But we are, and I should start by saying we are more software engineers, programmers. We're not domain experts at all. We're not scientists in this field, but we're trying to provide tools to the field, obviously. So Aashish is going to demonstrate a product or project called GeoNotebook, which was developed over the last couple years. And then I will show a newer project that's actually a Jupyter Lab extension. It's in many ways, we hope will replace the GeoNotebook, but we're just beginning. It's only a few months old. All right, if you're ready.
Yep. And since I just started the recording after your first introduction, I just want to say this is Kitware, and they're going to present their GeoNotebook tool.
So this is,
sorry.
Thank you all. This is Aashish. So I'm going to talk about GeoNotebook. This is the project that we started back in 2015 as part of the NASA AIST grant with NASA Ames. And what me and John are going to do today is, this is what I have done. So I'm going to show you how we can integrate some of the geospatial functionality within the Jupyter environment. And then John will show you the latest version with the actual water data that we have gathered with help from Berkeley. So this is the repository. It's fully open source, and it got actually quite a bit of limelight, I should say, because we got into the Hacker News as one of the top 5 news items, and then everyone started jumping onto Notebook, and that's why we see a huge jump in the stars of the repo. But I think what you will see is that what we have tried to do is really make it easy for the scientists to work with geosciences data within the Jupyter Notebook. So without talking too much about the system, I would like to show it to you guys what I'm talking about here. So this is what you get in the older version, which is what came from the NASA grant, is that you get the right panel, which is the map interface, and then your left panel is what you expect in a notebook environment. And to make some things work out of the box, we actually extended the kernel. So what you get, because we actually have our own custom kernel, is that you get a object called M, which represents the map, and then you can use that object to call, in this case, set center. So you can move your view to that location. And this is how exactly, at a high level, it works, is that we have a custom kernel that communicates back and forth with the interactive map. And whatever you're typing on the notebook cells eventually goes to the kernel, and vice versa. So this is kind of the communication mechanism that we have in our system going on that I'm showing you right now. So what we can do, we can actually do a couple of things. This is actually is using the IPy widgets. So you can actually create your own little widgets with very little coding, and then you can control the map. You can move the map left and right, changing the lat longs. You can also zoom in, zoom out. So again, these are some very quick, very small control that you can build yourself. Now, the biggest advantage that we have is that we can actually create annotations. So most of the geosciences require working with a small region of interest. So I can essentially create multiple kinds of annotations, and having it utilized in my analysis. So here, which I skipped some part, but essentially the map has layers, and you can query for annotations on those layers. So since I draw some points, I should expect to see at least one annotation here, which is showing here. And since I have one rectangle, I can get that rectangle back in my notebook. And similarly for polygon as well. So what's the advantage here is that whatever I'm drawing, the annotation on the map, I can actually get the same data back in my notebook environment here. So you can see this actually represents this particular polygon that I draw earlier. And since these polygons are actually Python shapely objects, you can get their coordinates. You can list a centroid, or if you want to calculate the area, you can do that actually as well. So again, some really quick functionality that you would do maybe on a daily basis. We try to wrap it as much as possible in the Jupyter environment. So let me show you something a bit more interesting that is probably going to be more useful for the scientist. So again, I started here, and in this case, I am downloading this dataset. So it's going to take maybe a few seconds locally to my machine. And what I will do actually, this is the raster dataset that I'm downloading on my machine, and then we can do some processing using the notebook environment. Actually, earlier, the reason you see this annotation drawn already because I was practicing that earlier, and the notebook captures that, and that's why it brought me back to the same state that I was earlier. So same thing here. You can set the map center here as well, and you can create the raster data objects in the notebook environment. So you can actually pass the file name, and that comes back as the raster data object. Then you can call the add layer functionality on the map, and if I zoom out, you will see, oh, it's coming in, I guess. It may be still creating the tiles actually, so it may be a little slow, hopefully.
The Zoom tends to slow everything down, Aashish.
But what we expect to see essentially is a new raster layer that should show up on the map. Looks like the file is still downloading.
Yeah.
So I think we still have to wait for a few seconds here. But essentially what you can do is that you can add the raster and vector layer to the maps. And what I will show you is that you can use this annotation to crop the data out and bring it back to the Python cell for further analysis. In this case, I will demo you the segmentation, for example. But since data comes as NumPy array, you can bring in any algorithm that you use currently and run that algorithm on the NumPy arrays that is sent back by this server back to the kernel, back to the Python cell. Looks like the data is still is being
93%.
downloaded. Any questions so far? Okay, so here it is. You can see this data is actually shown up here. And one nice thing about this notebook is that the data is actually tiled. So when you say add this data as layer, it actually automatically creates the tiling for you because there is actually a tile server running on the background here, and that's why we actually have to extend the Jupyter Lab or Jupyter Notebook to support server extensions to support tile server extensions on the background. So a couple of things you can do. You can obviously change the appearance of the data sets. You can actually compute the min and max of all the channels here. You can remove the layer if you don't want to show it up. You can again add it back. You can change the appearance. Now it's much darker. And if you don't like that, or if that doesn't really help you with the visualization, you can the data from the layer, and you can change, you can apply a color map to it. So I'll what I've done actually is I changed the color map here. So the color map I'm using is a winter color map on Matplotlib, and I'm using that color map to the notebook. Use your and pass that to the server to essentially get the visualization you need without doing too much coding. So now what you can do with these data sets, so like I was showing you earlier that I have drawn this annotation here, so I can actually get the data back as NumPy array, and you can see it here. Once you get the data as NumPy array, you can show it. Looks like it's coming out to be pretty dark actually. It may be because of my color map, but what you can do once the data comes as NumPy array is you should be able to do segmentation on the data, and hopefully this would work. Something went wrong. Let me. Looks like for some reason it still is thinking that the annotation 0, which I'm using it here, is one-dimensional data, or is a single point. Let me see it here.
Aashish, while you're figuring that out, we did have a question from Michelle. Michelle asked, "Is this Landsat 7 data? Can one of you answer that?"
You guys can't see it. It's very dark actually. But let's see if it try again. Let me see. Let me try it one more time. Yeah, for some reason, I'm not so sure why, but it doesn't seem to getting the right data back. Let me maybe I will clear all the outputs and then see if that fixes the problem. I need to do that. So let me see if I can get those. Get those outputs back. Nonetheless, I'll show you one more thing in the meantime while that is running, and hopefully I can still show you that how the segmentation is. But this one is showing you the actually not. This was. Let me show. So let me show you some of the screenshots in the meantime, because I won't have time to run all the notebooks. But essentially, what I was trying to show you earlier is that once you get the data back as number arrays, you can do segmentations. In this case, I'm showing it here. And then if you have these annotations that you've created using this small widget that we have earlier, then you can also generate your time series plots right in the notebook environment. So again, the trick is that the data come back as number arrays, and then you can plot the data using matplotlib, which generates a plot on the Jupyter environment. And this is the exact data set I was trying to show earlier, is where you can draw the annotations once you get the data back as number arrays from your annotation that you draw as a rectangle in the map. So what actually we have done is that you can do something on the map view, and you can bring that information back to the Python environment, or vice versa. You can actually create layers, add layers, remove layers. You can change their appearance. You can perform some mapping interacting operations, and those are reflected back to the map as well. So these both views are synchronized all the time. And for that, we actually have to extend Jupyter Lab, both the client server and the kernel, to make it work the way you're seeing it right now. So with that, I think I'll pass the baton to John and see if he can show us the latest version, which is still work in progress, and then show some data sets that we have acquired for the water data problem.
There was a question asked about the data you used in this first case. The question was, is it Landsat 7?
That's a very good point. The data set actually we use is, I believe it is Landsat 7 or 8. I don't remember exactly. But we do actually have the data hosted on our instance, so I can probably send a link for that. But it's a derived data set. Well, actually, I should either it's Landsat data set or it's the Weld data that we received from NASA actually. And I don't remember which data set we're using here, because we got the data and then we put on our own data server. So I don't know exactly where we originally the data came from. But I can have someone, if somebody's trying to use it, I can point to the data set, because it is actually publicly hosted right now.
All right. So I go ahead and take the screen from you there.
Sure.
All right. You'll have to release it. Or unshare. Let's see. All right, and let's see how we're doing on time. Okay. I didn't make any slides either, but some notes to kind of guide myself here. And there's a binder link for for the notebooks I'm going to show, or some of the notebooks anyway. However, Matthias got us far enough along that we could build the binder, but I still am doing something wrong in there. So the actual interactive displays are not working. At least they didn't work for me earlier today. So I appreciate your forbearance on that. But in terms of what I want to talk about is a fairly new project just started this year to take the capabilities that were developed in the Geo Notebook and build it as a Jupyter Lab extension, which basically means we don't need a kernel extension, we don't need a server extension, we just write a Jupyter Lab extension. It's more of a programming thing, but it makes life easier to install, but also more general, that more users can use this just in a plain old Jupyter Lab environment. The name of the project itself is Jupyter Lab _GeoJS, and this is the link here that you can, if you want to go to the GitHub page, in one sentence, what this extension does is it provides a Jupyter Lab interface to two different JavaScript libraries, one called GeoJS and the other is VTK.js. Both of those are authored here at Kitware. We specifically do not use Leaflet. Leaflet's a great library for displaying geospatial data. Its focus is more on GIS than perhaps scientific use, but also its interface is based on what are called the SVG layer of browsers. And we're using what's called the WebGL layer. From a user point of view, it's mostly a question of throughput. And I guess I should say GeoJS supports WebGL, SVG, and Canvas, all the layers in modern browsers. WebGL being the high throughput. So if you have big data, you'll find your leaflet will eventually slow down and not be usable in a very large, with very large data. But I don't mean to sound like I'm criticizing. Leaflet's a great tool. But GeoJS, we try to duplicate some of that functionality, plus tailor it more for geophysical, geospatial applications. And the second library, VTK.js, is actually a three-dimensional library that takes our original work in visualization and brings it to the web. So almost everything we do at Kitware is open source. Oh, didn't mean to do that. Let me come back here. We love developing software. We're not that much into packaging and selling it. We'd rather get it to the user community and see what they can do with it. What I am going to show you is a Jupyter Lab extension, and I'm not sure we did a good job describing what Jupyter Lab is relative to Jupyter, but this is the newer user interface that the Jupyter team has adopted. We made a decision not to support the older interfaces, and if you really are moving forward, we certainly would encourage everyone to stick with the Jupyter Lab interface. And as we said before, it is a work in progress. So we'd love to have people try it, but as long as people understand it, it may change. We may break it from time to time in order to make better, to improve the API, make a better interface. All right. Finally, in terms of what is actually hosted on Binder, you should see a handful of notebooks. I'll go through these pretty quick and then also show just some things we did last week with Valerie's data, just to test drive it with real data instead of our homemade test cases. So what I wanted to first show was just to display a map. You basically need 4 lines of Python here. Jupyter Lab GeoJS is the name of our library, and it has one class. We call it a scene now. And you import that, and Python programmers should know how to import objects. And then you just instantiate it. You create one object, and we just call it the same name. And this object is really has the mapping interface in there. Basically, we build it up by layers, and you build your map one layer at a time. Layers let you put things in front or behind each other, as well as hide and show things. But to show just a map, you create a layer called, and we call it OSM. OSM stands for OpenStreetMaps. It's a standard for mapping tile servers. And so we've just adopted that term. There's nothing magic about it. Then you just display the scene, and now I have a map, and I can, well, I won't navigate too fast because that'll probably doesn't share too well on the Zoom. And there's many features you can add to a map. And so in the next cell, I've just set the center and zoom in. I happen to know I looked up the coordinates of where Kitware is. We are in a town called Clifton Park, New York, which is in what we call upstate New York, kind of between the Catskills and the Adirondacks, if you know this part of the country. All right, let me move on to the next notebook. We've implemented kind of the standard mapping features. I won't walk through this too much. see the same basic logic up at the beginning, where we're creating our OSM layer. Here I'm setting the center and zoom up front. And now I'm creating a second layer. We call it a feature layer. And in there, I'm basically pasting some simple data, just demo data. So we have just a list of cities with some corresponding information. We set aside, we grab the positions, I set a few style variables, and I create what we call a feature. I called it points here. And on a layer, we have a method called create feature. We tell it to type, and there's various options you can pass in there. Similarly, I pasted a simple rectangle here to show that we can do points, lines, rectangles, and I guess I didn't do a polygon, but polygons. Same thing in the same feature layer. I call it create feature. Here I pass in a different name called quad, and I just pass in different data. Here I just pass the coordinates, no other data associated with it in some style. So when I render that, let me scroll down. When I display that, you can just see the handful of points are displayed as circles, and the quadrangle the rectangle is displayed. Well, and I'll just mention in passing, we also support the GeoJSON data style. I create a map. I set our center and zoom. I create a OSM layer for the map itself. I create a feature layer. And here I'm adding data several different ways, but basically I've grabbed in code, I've just generated the coordinates for a polygon, and I call create feature with the data. In this next cell, if I'm highlighting these or not, in this next cell, I'm actually loading a local file, this file here in my file space as a file, and that contains the points. Yeah, contains points in various cities in New York. And the third thing I do is we can also download files. So we've just had a small GeoJSON file on our data server. So we pass it in as URL. So we pass it in as data, file name, URL. There's 3 different features here in this display, and it's just, as you can see, the polygon, and there's some lines in there. We did this just to convince ourselves that everything works okay, basically. The next and other capability is, I'll jump to the next notebook. Here is just a raster feature, a small raster feature. I create the scene, create the feature layer, and now I create a feature called raster, and I'm passing in a GeoTIFF file here, it's a small test GeoTIFF file. Here I'm only setting a opacity on it so you can partially see through it. And this code I don't want to dwell on, but basically we are extracting the corner points from that TIFF file and using that to set the location of the view, the camera view. So this is just some small GeoTIFF file that was captured in somewhere in South America. All right. And then lastly, we are, and this is definitely a work in progress with point cloud data, which is 3-dimensional data. And so this is another test data set. You can see I can move it around. I have some slightly more interesting data. But this data is separate from what we're doing in the maps. Our intent is to converge these in the future. So here, let me just load a slightly more interesting data set. I don't know how well it'll come through, but over on the left-hand side, and this data came from what's called LIDAR measurement. You folks must know what that is, where they scan some area, and it's basically a bunch of points, a bunch of X, Y, Z, and related data, and we just lump that all together into a big data set. And if I zoom in enough, you can see that these are actually individual data points that are displayed. In this case, it's just little squares. But because the data is enough density, you can infer features here. So on the left, there are trees. I'm not sure if this is a crane or something. And the color mapping is just very trivial. We just have a plain old red to blue color map right now. But this is the capability that we plan to integrate and add. This is part of the work in progress. And let's see, we don't have time. Just to let Sharu know, we did load one of your data sets. I just grabbed one of the very smallest ones. Not yours, but one of the ones you folks provided us. And there's not a lot of contour in this one, but we just wanted to make sure we could at least load your data files. All right, so that's kind of the development of the new extension. I'm going to switch to a different notebook that is not available on Binder right now. So I went through the examples. These are the different examples I walked through. And then, as I say, Valerie provided us some data that she was working on, and we just made a couple quick notebooks looking at the pond locations and the TDS data, really, by year and by year. So I'll first just show the pond data. Again, we're creating one of our scenes, setting it center. And what this logic is doing here, instead of using a default map, we're using a map from the Stamen family, Stamen company. They make one of them publicly available. And the only reason I use this is because it's a black and white map, and it was easier to see when we showed all the colors. Then let's see, in this next cell, I created our field layer. I created a layer for field data. And here's where I loaded this file called boundaries.shape. These are the boundaries of the oil and gas fields. And then in the last cell, now on my screen, this is getting clipped. That looks better. So these green colored polygons are the oil and gas fields. Then in the cell above it, I basically am loading her pond data, I should say, and I'm mapping that to points on this display. There's a lot of code involved in the cell to extract the data, and basically format it for our extension. All that should go away, and it should just be one or two function calls that say, here's a data frame. These two columns are the X and Y coordinates, and here's the data I wanted to display with it. So just displayed some points for each of the ponds, and I added the ability to just put the metadata in a pop window. So I hover over one of these. This is just a simple text display, but we show this. This is the data that was actually loaded in from the original CSV file. It's in the data frame. Just looks like about 10 columns, and for each column we list the data. I'll think out loud. I think Aashish and I should talk about, instead of doing this as a pop-up, maybe we should have a little sidebar or something. It can be a little distracting if you're not looking for this data when you navigate around to see it. All right. I'm going to switch to a second notebook. This one incorporates basically a large data set that, again, Valerie generated by, I believe, combining data from several sources. And what we did here, let me come back to the top. So we created layers. I'm using the same map. Putting the oil and gas field boundaries in through the same, that's just a copy and paste. Now I'm reading her new CSV file. And let's see, for my convenience, I'm doing a little pre-processing. She probably did something like this, but I'm dropping the columns where we don't have any TDS or coordinates or year data. And so we're just dropping those out. So our original data had 21,000 rows in there. We pulled out some that had some missing data, more for my convenience. So there's 18,000 rows in the data I'm actually working with. And some other things here, we're just copying or converting the year from a floating point number to an integer, things like that. All right, so this looks redundant. Oh, well, looks like I pasted the same cell twice here, so you can ignore that. Now I create a new feature layer for the TDS data. And in this cell, I'm just extracting the ranges. What are the min-max years that we have data for? And what are the min and max data And actually, instead of grabbing the maximum data, this line here, I grabbed the 90%, 90th percentile data is what this will give me. Since the data is very skewed, very nonlinear, so from 0 to 1300 is what we'll set our color map to. So anything over 1300 right now, we're going to end up mapping just as maximum. All right, here's some standard Jupyter logic to and I'm not a Jupyter programmer, but I learned enough. We made a little display widget, which might not be the best user interface, but what you can do here is we let you select a range of years. So I think from 1909 up to this year, you can specify, I only want to look at data from this time frame. So we can down select by year using this little widget here. That's just standard Jupyter stuff. So I've set it to just last year and this year, 2017 to 2018. So of the 18,000 rows, that down selects to 393 rows. And I've skipped over some parts, but I've also down selected to just display 6 columns of the data. And let me scroll down here. So again, I do some Jupyter logic that in a future version of our code, this will be one line, just say, use these columns. I clear my feature layer so I can run this over and over. I create a point feature, and I set some default style here. I skipped this line. Enable tooltip is the thing that allows the little pop-up windows to display. I enable that. And just late last week, we added a color mapping feature where you specify which color series do you want, which field in the data do you want to color by, and what range do you want to color over. In this case, that's from 0 to 1300 in the TDS score. So when I display that, hopefully this is displaying okay. You can see the same kind of thing. I'm not showing the ponds now, but where the TDS data is. And it's just mapped from blue being low TDS values to red being high TDS values. So if I hover over one of these, you can again see the metadata that I've included. And I can see for this case, the result is 6,600. And for one of these blue guys, it's quite low at 280. All right, so that is, where'd it go? That was what I wanted to show. But I meant to mention, so now this software is just a component that you can use in your, and of course it's interactive. A component you can use in your workbooks. It's not something you don't need to install a kernel extension or a server extension, just the Jupyter Lab extension. And, okay. So let me come back to my notes here. So this is what we've got. There's where we are at so far. In terms of where we want to get to, like all programmers, we want to get to a software release maybe this fall, soon. This year, certainly, we want to have this to the point where people can use it, can install it without a lot of hassle, and find some usable documentation. We need to do more work on converging the 2D and 3D capabilities. We'd certainly like to be able to show that point cloud data in 3D with some kind of background map that's also in 3D, but that's to be done. And where we're really headed is this last thing. We want to approach large-scale applications. Once again, didn't mean to do that. Where the data can't just fit in your local computer there. And that work will incorporate using another Kitware software called Girder, which is really a data management platform for holding the data in a server, either cloud-based or network-based, doing things like tiling large-scale images, which GeoNotebook does, and also doing the 3D equivalent of tiling large-scale point cloud data, so that you can be interactive on your local host while having large data sets available to you. All right, and with that, I think that's everything I wanted to cover. So we're well ahead of our schedule, but if there are any questions or things we want to do, we certainly will be glad to try to answer them.
So let me share my screen real quick, actually.
Yeah.
So I have a quick question for those of people who saw Michelle's demo earlier and saw the leaflet interactive maps. Can you both just give a little bit of perspective on sort of the different
So I guess since we have some
underlying?
extra time,
Can you hear us?
yeah, it looks like the notebook went out of sync last time. So here, this is what I was trying to show earlier, is that you can draw an annotation, you can get that data back as NumPy array, which you can pass with Matplotlib, which can plot this data. Again, this is more for the validation purposes. And then what we have done is that we actually use the scikit-learn image segmentation here to draw segmentation on that small data that we clipped from the large data set. So here we are showing that segmentation results back again in Matplotlib. So again, this is to show what the possibilities are that in the version that John showed us just a few seconds ago, we would like to incorporate all these features that there actually as well. It's just that this version is not using the Jupyter Lab, and we are moving towards Jupyter Lab because it allows us to build these extensions much easier way, and also provide some robustness that we're hoping to get from the system. The one interesting thing is the features. The idea is that how we can build this feature set, whether those are widgets or those are APIs that are either built into the Jupyter itself, that makes it easy for the domain scientist to create or execute these functionalities without typing too much code or without learning the details if they don't want to. So that's really the motivation that we are putting forward here. And then obviously it all has to be open source to attract and to build the community around the Jupyter Lab and the extensions that we are building within that. So that's the summary of our presentation so far.
Did you put your speaker on it? Drew's been trying to jump in here. Sorry.
Oh.
Thanks, John. Can you hear us now?
Yes.
Yeah, sorry.
Yeah, so I just had a question for those who saw Michelle's earlier presentation with the leaflet interactive map. Like, if you could just get a little bit of a, higher level perspective on how your product layers on various different map layers. I know you sort of showed the map layer on your demo, but just, letting them know that, you should OpenStreetMap, but that you support, underlying layers is sort of like not, not a requirement.
So the question is that, well, I guess, so, okay, maybe I'll try to explain. So based on my understanding, so the base map is not a requirement here in this case. We are drawing the OpenStreetMap just to show where you are in the world. But actually, let me see if I can change that in my demo. I think in this demo, actually, it's hardcoded. So in theory, you don't actually have to add the base map. You can just work directly with any of the raster and the vector data sets in our case. Leaflet, I don't know if that's possible or not. I think it's probably possible there in Leaflet actually as well. But each of these layers are essentially, or each of these data sets are, in this case, are drawn as layers. You can actually draw data into the same layer as well. It's just that when you toggle that visibility of that layer, they all will toggle at the same time. The difference between Leaflet and our case is that Leaflet actually is using SVG, which is vector graphics. I said it worked great. I think once the data gets bigger, that's why it has performance issues. But the underlying principles of that's what we are doing here. GeoJS as well. Did I answer your question, Charu?
Yeah, you did. Thank you.
Maybe.
If anybody else has questions, can you please
So
pop
one
it in
thing,
the chat?
since we So one thing I want to quickly show you is that what John said earlier is most of these libraries that are out there, like Leaflet, OpenLayers, Mapbox that you may have heard of, they are mostly focused on GIS. And that was not the intention for the GeoJS. Even though right now you're seeing these plots as 2D plots, what John was showing you earlier, that the point cloud actually was in 3D, and that was actually drawn in using GeoJS. And the other big factor is that the focus is more towards the plotting the scientific plots. Like contour map is very popular, very usable plots that you always, most of the people want to draw it for the earth science data sets. So the GeoJS allows you to build these high level feature sets without you need to figure out the algorithm to draw contours or heat maps or vector plots or other kind of plots that are typically used by the scientist. So again, that's the kind of the basic difference between where we are heading towards what we are building open source as opposed to what other tools, especially in the GIS worlds, are doing.
Great. So I encourage everybody to go look at their website and look at some of these examples if you want to learn more about their tool. So I think we're a few minutes early, but there's no reason to not wrap up early. If you don't have questions, I'm just going to start the wrap up phase if you guys are done, John and Aashish.
Yeah, I think we are done. Sure.
Okay, and if you had questions, we can always get back to them. So please put them in the chat window. So Meredith wanted me to thank everybody for attending. First of all, this is really great, and we got 50 participants, which is really great to see everybody here. And hopefully you all learned something and are able to use this tool for some water data analysis. So just as a quick question, maybe for either Valerie, for Valerie, let me start asking you that question. Is there any particular Jupyter tip or trick that you wish you had known before you had, dug deep into this?
Jupyter tricks? No, just learn how to use Stack Overflow and Google whatever you need for documentation. I don't think there's any tips that I could offer unless you have a specific need for something, which is not the same for everybody. I think that this challenge will help with the only things that I could give you tips on, in the sense that it was very difficult to find some data and took a lot of clicking and research and trying to understand what the data meant, and then trying to find some form of documentation that was telling you what was in the data. But I think that this data challenge is trying to work around that.
Matthias, do you have any good resources for tutorials other than the website that they could, you could point people to if they needed to, pick up some Jupyter, get jump started on this tool?
So we gave a tutorial last week at SciPy, who should be recorded or should already be online on YouTube. If you search for Jupyter Lab tutorial SciPy 2018, there is 4 hours video of me and Jason Grout going through an introduction. Well, from I have never used Jupyter to I'm writing extension for Jupyter in 4 hours. That should give you a nice way to start if you've never used that. Otherwise, one tip, if you want to really be proficient, learn about the keyboard shortcuts. That will make you way faster. And I will try to provide the link to the video in the chat.
Thanks. I think Meredith, you had a question?
I wanted to ping all of the speakers on, particularly for water data, what they try to keep in mind when you're working on water data, and any advice that you have for the challenge participants working throughout the summer.
So I will chime in here and mention that some challenges working with some of these water quality data sets are that there are quite a lot of anomalies that have to be scrutinized to make sure that they're just anomalous sensors measuring something random, and that you are looking at real data. So that is one thing that I'm currently working on with some other folks, is how to better make sure that the data is good data and not, you know, an outlier that's not representative. So more of that QA/QC approach, I think that has to be a main focus of the analysis before reporting on the values.
And I totally second that. I think that QA/QC tends to be a black box sometimes, and pre-processing of data, and that's really why it's great to do Jupyter, because it can be very transparent as to what happened to the data before it actually got used in your analysis, which is something that's always missing, and people take that part for granted. But it may be that you're removing an outlier, which is actually a real data point that's useful, and so it's good for people to see the pre-processing. I think the other sort of challenge that we've had with maybe some of the state data sets is that things like the metadata and finding some of the metadata and being able to use some of these fields, like for example, we had to communicate directly with the stewards of the data to figure out what is the unique well identifier, or the unique thing that we should be grouping our wells by. So that's another challenge, is I think just getting the right metadata and figuring out how to use the data. That's hopefully one of the things this challenge can help point out to all the stewards of the data, is what people need in terms of being able to use the data sets.
I would agree, and I'd also just like to say, if you are looking at the same data sets that you've seen in my Jupyter notebook, feel free to contact me and reach out, and if you have questions, I can tell you tips that led me to where I was, or links to the websites that explain the data a little bit more.
Yeah, I think one thing I would like to say, that I think Jupyter Lab and the tools that we are building definitely helps you doing things faster, but if data has anomalies and other issues, you still would require to clean up the data sets. I guess one thing would be, we can think about maybe is how we can represent those anomalies for QA/QC purposes. In fact, the reason actually we built GeoNotebook for NASA was to support QA/QC, as NASA actually does a lot of these products development, where they actually take the raw data from satellite and convert it into something which can be consumed for the analysis, or second, they call it these NASA products, which actually could be doing reanalysis, for example. So I guess what would be interesting is that how to tackle these anomalies early on, and how do we can represent them, so when you bring this data into the Jupyter environment, we can find those anomalies early on, and maybe that will help with the analysis and improve the efficiency of doing these analysis. One
One last-
other question
Oh, go ahead.
No, one other question I want to ask this group here is that in terms of the data size, I know that I think Matthias did presentation on the task-based workflows. Are there any challenges in terms of the data size for the water data analysis? Is data too big, or data is somewhat reasonable right now that you can still use your laptops or desktops for now?
So I will comment directly on that in an analysis I'm doing at the scale of the United States. So I showed the analysis for one station, and I cannot do this analysis on my laptop when I scale it up to the United States. So I have to use NERSC in order to do this. So it is a challenge in that way, and I thought it was interesting that we saw that notebook earlier where Matthias was using a link to some clusters to run that. So I think I will be interested in learning how to do that for my own work.
So for those of you who aren't familiar, NERSC is Berkeley Lab supercomputer. And so it turns out that some of the data sets Michelle is running at least is beyond the scale of a regular laptop. In general, though, for a lot of the state data sets, at least for California state data sets, the data are not that huge. They're in the data sets that Valerie was using was about half a gigabyte total. So it's not like in the petabyte scale or even terabyte scale for at least the state data sets for the purpose of this particular challenge. But as Michelle mentioned, when you're trying to scale up to the CONUS, the continental United States, or maybe larger scales, then, or you try to do some modeling simulations, then that's when your data starts to get really large.
Yeah, no, I think that's interesting. So one thing actually, which John mentioned, is we have a tool called Girder, which is for the data management. And what actually we are doing is we are bringing that data management within the Jupyter Notebook, and that actually tool also has a plugin to run jobs at NERSC. So our grand vision of these things is end-to-end workflow, which means that you can store your data or expose your data through this Girder system, which essentially provides you a unified API. And when I say unified API, essentially it's basically a RESTful API that you can query your data sets, and then you can bring those data into Jupyter Notebook. You can do your analysis or visualization, and when you're ready to do your job submissions, our hope is that you can use this plugin, which actually essentially runs your analysis code with the data managed by Girder on the NERSC system. So that's something we actually have already shown some examples, not to this group, but to the other groups actually in the past. And we are hoping to bring that to the version that John showed us earlier, where you can do end-to-end workflow using all the open source tools that allows you to run jobs at supercomputers with very few clicks from your Jupyter environment.
That's
Well,
really
I would
cool.
like to tag on to what you were just saying. In order to create this workflow from data to running models and to have that all available on a cluster or supercomputer, one of the things that we really have to have is a way to, well, not only do QA/QC on the data, but to have the data continuous and to be able to have these methods that are different methods depending on the type of data for gap filling the data. So for example, temperature that you were showing or precipitation data sets, we can't run models if there are gaps in those data sets. And a lot of the work that we're doing at the lab is trying to figure out what are the best ways of gap filling these data to then run our models. And so that's a big research area that I think having this open data and Jupyter Notebooks for doing that makes it more transparent, because most people run the models and they just put in, their own choice of the number to fill those gaps.
I just wanted to chime in, lest we end on a impression that you need a supercomputer to participate in the challenge. I'm seeing a lot of smiles. It's not the case. If you are interested, however, in looking at experiments and lines of inquiry and such that are beyond your individual computer's capacity, please do reach out. I'm actually at a workshop, show this for everyone, that has over 34 universities and colleges from across the US. And the hub is particularly interested in water data analysis, where we bring in not just California, but also regional data. And so I can imagine that we would be able to work with partners, as we have done in the past, to try to provide some cloud computing resources if you're running up against that issue. So please do reach out if that is the case.
Great, thanks, Meredith. So if there are no last burning questions, I think I'm just going to end with sort of a positive note, maybe with all the speakers. If you could chime in on maybe what advice you'd have for challenge participants to get started, that would be great.
My advice would be to try to run some of our binder links and to run like the code that we provided in the website for this workshop, and to send us. You can feel free to send me some questions if you have any burning questions about how I did the analysis, or if you run into a problem with the code. I think that would be a great way to get started.
Don't be afraid to ask and share what you're doing. I had a good experience during my PhD to say, well, nobody is going to look at what I was doing. I'm going to push it on GitHub. And got some random people coming around and say, hey, if you do that, you're going to speed up your method by a factor of 20. So that was great. Always good experience and talk to people.
I would also say don't be afraid to reach out to the agencies themselves. We've had a lot of positive feedback and people from the State Water Board identifying that there was a problem with what they had and fixing it for us as fast as they could. So don't be afraid to reach out to the agencies themselves.
Aashish or John?
I think we would add, of course, never be afraid to use Google, and especially Stack Overflow to start your questions.
And please share any useful resources to the Slack channel for the Water Data Challenge. Part of the beauty of having it over several weeks and the entire summer is that there's lots of folks who are working just like you, and you're not alone in trying to navigate all of this. And the data stewards are there. So next week, I think it's next week, yes, on our Google Calendar, there's actually another virtual fireside chat talking a little bit higher level on lessons learned on the Data Science for Social Good program, which has teams of people working on problems of social impact, and then also some offers for help and resources from the National Data Service. So there'll be another, it's not the same bat time, bat channel, but it's on the embedded calendar.
So one question I have is that the challengers, can they choose any tool they want, or are there limitations as such?
It was breaking up a little bit, but I heard the first part of your question about using whatever tools at the participants' disposal, and we absolutely encourage that. There are different awards for people who are providing solutions where it's open source versus proprietary methods. In general, whether you're looking at having everything completely open, or you're a startup and you're working in this area and want to show something really neat, the explainability and interpretability, and sort of, as Michelle and others have noted, being able to walk through why your model or prediction or end recommendation is the way it is equally important. But it's, any tools and even new data sets are open for being brought in for this analysis.
Yeah.
Great. And there was a question about getting the contact details. Just so if you go back to the website, we have the links to everybody's bios. So you do have their contact details. But and also, I think their contact details are at the bottom of everybody's Jupyter notebooks. But we can also send out an email to all the participants, just reiterating that. So there are no further burning questions. I think, I'd like to end on time. This was really great. And thank you to Meredith and to the Water Data Challenge for giving us this opportunity, to showcase Jupyter as a great data analysis tool. And Berkeley Lab is really excited to have participated in this and hopefully contributed to some cool things. We will look forward to, if there is any submissions using Jupyter, we would be really excited to know about it. Fingers crossed, and hope something comes out of this.
Great. Thank you so much.
Thanks. And we'll share the recordings at the end, along with the email that goes out to all the participants.
Thank you, Meredith, and thank you, Charu.
Thanks, everybody. Bye.
Bye.
Thanks, everyone.